Question 1. Simplify a cubed times a to the power of 4. To multiply terms with indices, add the indices. So in this question we get a to the power of 7. Question 2. Simplify 2a squared b times 4ab squared. We multiply the front numbers normally. 2 times 4 is 8. And then we add the indices. So we have a squared times a. Now that single a can be considered to have a power of 1. So we'll be adding the indice of 2 for the a squared and the indice of 1 for the a. And we'll get a final answer there of a cubed, remembering that a times a is a squared or vice versa. And a times a makes a cubed. And we'll have a b cubed as well. We get that by considering that b has a power of 1, and we've got b squared. So the indices for b are 1 and 2, so when we add those indices together, we end up with a b cubed. So our final answer, 8a cubed, b cubed. Question 3. Simplify m to the power of 5 divided by m cubed. To divide terms with indices, subtract the indices. Final answer, m squared. So we've done 5 minus 3 and got a 2 for the power, so m squared. Question 4. Simplify 3x squared y all over 6xy. We divide the numbers normally, and we cancel down letters where possible. We cancel down by finding a number and or a letter to divide into the top and bottom of the fraction. So we'll do that with the numbers. 3 goes into the top once, and into the 6 twice. We also have x that can divide into the bottom once, and when x divides into x squared, effectively it cancels out the squared. Because if you imagine we have x squared on the top, we have an x times x on the top, and when we divide it by x, it cancels out one of the x's. It's a long story, but in the end, it effectively cancels out that squared, leaving us with just an x on the top. And I think you can see that we can divide y into the bottom, it goes once, and y into the top going once. It's really good to put those ones in there, because in a certain circumstance, that gets us out of trouble. So on the top, we can see that we have 1 times the x that survives, and times another 1, leaving us with the top being x. And on the bottom, we have a 2 times a 1 times a 1, so we end up with a 2 on the bottom as well, on the denominator. So our final answer ends up being x over 2, but there's a lot happening in that question. Question 5. Write your answer in simplest index form for a squared all to the power of 4. When a power is put to another power, we multiply the indices. So in this case, we'll multiply the 2 times 4, and we'll get a to the power of 8. We multiply the indices in that situation. Question 6. Write your answer in simplest index form, 2m cubed all to the power of 2, or 2m cubed all squared. Now that front number, the 2, in front of the 2m cubed, we put that front number to the outside power. Now the outside power is a 2 or a square there. So we put that front number and turn it into 2 squared, which we know makes 4. So our front number ends up being 4 or 2 squared there. And then we multiply the indices. So m cubed all squared, we multiply the 3 times the 2 to make the new power, and we get m to the power of 6. So careful with that front term there. Question 7. Simplify writing your answer as a whole number. 3p to the power of 0. This is a funny old rule, this one. If any item has a power of 0, that item equals 1. So we have 3 times p to the 0. Now we'll notice that it's only the p that has the power of 0. The 3 isn't being affected by that 0 because we don't have brackets around the 3p. So it's 3 lots of p to the 0. In this case we have 3 lots of something that equals 1. So the p to the 0 part becomes 1, and we just multiply that by that front 3. Final answer, 3. Question 8. Simplify writing your answer as a whole number. 4m all to the power of 0 plus m to the power of 0. If any item has a power of 0, that item equals 1. Now in that first bracket, that whole bracket is put to the power of 0, so that whole bracket ends up equaling 1. And in the second part, the m also, m to the 0, that part equals 1 as well. So we've got 1 that the 4m became, and we've got a 1 that the m to the 0 became. So we're asking the big hard maths questions here, 1 plus 1, and we get 2 for that. No surprises there. I hope you got that correct, especially that second part. Question 9. Express using positive indices n to the power of minus 2. Okay, to express this using a positive indice, if any term has a negative power, the fraction version of that term can be turned upside down to create a positive power. So let's see how that works. If we put n to the minus 2 over 1, and anything can be expressed as being over 1, and then we turn that upside down, we get a 1 on the top, and notice we get an n squared on the bottom. So turning that original term into a fraction and then turning it upside down, we can think of that as using up the minus part of the indice. Question 10. Simplify writing your answer using positive indices a squared times a to the power of minus 3. To multiply terms with indices, we add the indices. So if we add 2 and minus 3, we're taking away more than we've got there, so we end up with a to the minus 1. Now, if any term has a negative power, the fraction version can be turned upside down to create a positive power, because the question asked for us to use a positive indice in our final answer. So what we'll do is put the a to the minus 1 over 1, we'll turn it upside down and end up with 1 over a. So when we express that term as a fraction, and we turn it upside down, it effectively uses up the minus part of the indice. Now that a in our answer on the bottom there, on the denominator, effectively has a 1 for its power, but we don't have to write that in.